important points, kind of as a bit of a prelude to what we're going to talk about today with the specifics of the network. So we can briefly recap that. But first of all, let's jump into some quick intros here. Jessica, why don't we start with you?
Hi, Jessica Levesque. I'm the Executive Director at C4. Thanks for joining.
Mr.
Hi, Dustin
Shine,
here.
or Dustin.
Hi, Dustin here. Based in Singapore, I run the community E65, and yeah, I'm working with C4 as education manager.
I'm going to jump now. I'm Cheyenne. I'm chair committee at the CEP committee, and yeah, more on background in security. Been in Ethereum since the first fork, I guess. And yeah, that's all.
Sure, I'm Josh. I'm one of the board members of C4, one of the founding members. Sit proudly on this certified Ethereum professional committee. And in my daytime, I'm building games in the Web3 space. So having fun with that.
And I'm your moderator.
And Kent.
My name's Kent. I am an ETH Denver steward, formerly with both Shapeshift and Shapeshift DAO, where I worked on tokenomics and R&D stuff. And also a member of this very committee, the CEP committee, Certified Ethereum Professional Committee, which, by the way, if you ever want to learn more, potentially getting a certification that can help you prove your crypto knowledge to potential employers or other interested parties, check out our site. Just type in C4 crypto and you'll find it. So Josh, just quickly back to you. Let's just quickly kind of underscore what the difference is between, what's going to be happening shortly with Ethereum and just a typical app upgrade where, oh my God, Lyft just pushed an upgrade and I have some new functionality. What's the difference here?
Oh, I mean, the difference is that, big kind of key concept of control. Who has control over this process? In a classic upgrade, some company decides that a new feature is being implemented or some bugs are being fixed. They work all that, behind the scenes, and I wake up one day and my phone says it's been updated, or it failed to update. It just couldn't handle it that night. But usually, it just kind of shows up and it's done, and you don't really think too much about it. Now, you might wake up and a feature is there that you might like now, or a feature that you liked is gone, but not really much say in the process, other than voting with your money as a consumer, deciding to keep use it. The upgrading of a decentralized network is a little bit more. I don't know if involved is the right answer. Involved might actually be the perfect word for it, because really the community needs to actually come together, understanding what of these features need to be implemented, how they're going to be implemented, assuring that they're implemented correctly. And then ultimately, it's us as members of the community that decide to run it. We're not, waiting for our phone to say, hey, it's been updated. We're looking at it and making conscious decisions a lot of the time, say, yes, this is the Ethereum that we believe in this case. Now, not every user is going to do that, and not every user necessarily needs to know every portion of say Ethereum. But as far as how it works in the backend, there's many people, both technical and non-technical, that work very hard to make sure that this actual upgrade process is synced along the community and actually succeeds when it gets put into place.
Awesome. Yeah, well said, Josh. So another interesting facet about Ethereum upgrades is it's very rare. Or maybe even unprecedented for it to just be like one thing. Usually these upgrades encompass a whole host of upgrades. Some will get more attention than others because they're potentially more impactful to whether consensus or scaling or things like that. But you hear about EIPs, and just to briefly cover that again, reiterate, like there's probably, gosh, 7, 10 EIPs in DenCun. There's many. And DenCun is the name of this upgrade. Dustin, again, what are EIPs, and how does this relate to the fact that Ethereum has both like two different layers or elements working together?
Sure. EIPs are Ethereum Improvement Proposals, and it was taken first Bitcoin Improvement Proposals, and before that, actually, I think it was Python that had Python enhancement proposals. So what it is it's a process through which the community or the developers propose changes to the protocol. Now, this requires a lot of coordination because, as you might know, Ethereum is a multi-client network. So what happens is that you don't just have one team working on the nodes, you have multiple teams working on different implementations. So you might want to do an upgrade, but then maybe this particular programming language has a different way of implementing it. So you need to have these discussions somewhere, and people are impacted. There are different, members of the community, the users, the developers, the app developers, which are different from the core developers, and they all have different things that they want to do. The core developers want to make the protocol robust. They want to add scalability to it. They want to clean the state. They want to reduce bloat. They want to make, it easy for people to run clients. And then app developers just want to be able to bring software to users that users want to use. Users just want to use it. They don't want to pay high fees. They want it to be easy to use. So with all of these different, people and communities pushing and pulling, EIPs are kind of like a start for people to discuss and then to come to a community consensus on what the best way to move forward is.
Awesome. Thanks, Dustin. So yeah, let's kind of turn our attention now to what is, I think rightly so, getting the most attention amongst the various EIPs in DenCun. That would be EIP 4844, also known as proto-danksharding, which sounds just almost like an insane made-up term, which hey, it kind of is. We're all making this up as we go along, but you'll soon understand kind of the logic behind that. But the key thing to know with this upgrade, because it figures heavily into Ethereum and its ethos and its approach to scaling. Scaling is basically how do we include more transactions on the network. This is super crucial for you guys to understand. The easy way to scale a blockchain is just to have bigger nodes and have increased computing requirements. So basically you can easily process on the blockchain more transactions. The problem with this is it's not very decentralized because it limits the number of participating computers, basically. So that's kind of the naive and easy way to do it. Ethereum has always been sort of fundamentally opposed to that approach. And maybe there will be some ways to do this in the future. However, instead, the community has opted for an approach that relies on what's called rollups, or also they can be kind of conflated with what's called layer twos, where you have other blockchains that live separate from the L1. They kind of do their own thing, but then they're able to use the main network, the Ethereum network, which has had close to 100% uptime, and it's been live for so long. It's relatively very secure. They use that for security. So basically what 4844 will do is facilitate scaling and cheaper transactions on these rollups. That's kind of just a lead into this, but Cheyenne, would you mind explaining a little bit more kind of what exactly is going on with 4844 and how is it so crucial to this emerging rollup centric world that the Ethereum ecosystem is kind of moving into?
Yeah, Kent, thanks for the explanation at the beginning. So a lot of layer twos that you were mentioning, they use the security of layer one. And in order to do that, you need to come back to layer one, which is base layer Ethereum, to write down. You can see it as these checkpoints or these places that you need to put the proof on chain to be sure that everyone can come back and verify everything that was happening on that other chain or that layer. And a lot of times it's just a chunk of data to be put on the nodes. They need to verify. After verification, they almost can get rid of that data. They don't really need that anymore, just for proving it. And basically, there were a lot of conversations before, as you were saying, proto-danksharding seems like a made-up name, which it is kind of a mash of a bunch of other names. Sharding was the first idea to have 64 or 32, I don't remember, shards. But then they were oh, we don't need, it's too complicated. Let's try to do something else. So the proto side came in. I was let's prototype something. And then, and the Dankrad is the guy behind the idea. So we kind of mixed everything together. And the idea basically is to have this data live on every node for some time till the end of life. You verify you do all the checks, and within like 28 days or I think a month, you can get rid of that data. You don't really need that anymore. And that's like a basic idea of it. But I know like Dustin can go in more details on how it works, or so Josh on mute also if you want to jump on it.
I was just going to jump in because it sounds like such an easy concept that we would normally use. Like, oh, I don't need this data anymore. We can get rid of it. But one of the biggest parts of these blockchain systems is that the data being immutable has always been important. We can look back and see the history of things, and that history is kind of what we're all working to. It's why we trust what we have now. We can see the history, and now we know exactly all the balances. So it sounds like such a simple, obvious thing to introduce into Ethereum, but at the same time, it's a fundamental change now to realize some data is actually some data only needs to matter for a little bit of time. So I think that was like probably a really big fundamental shift that had a lot of discussion in that EIP process. Go ahead, Tristan.
Yeah, I think that the main issue here is that there is data that is necessary for the rollups to be able to post to L1, and it's data that is useful for a short amount of time. So think of it as maybe it's like working on a math problem or something like that, but once you have the answer, you don't need the working anymore because you've already got like what the answer is. So the idea basically is that if you have it on-chain permanently, this is temporary information. You know what your temp directory on your computer looks like, or your desktop. So imagine like a really messy desktop that you have for life because you can't get rid of any of it. So what this allows Ethereum to do is that it allows them to have this data that is important because it needs to live on chain for some time. That's the data availability aspect of it, because it needs that data to be able to verify that these transactions are legitimate. And whether that's done with optimistic rollups, which use fraud proofs, or with ZK rollups, which use ZK proofs, that data still needs to exist on chain for these transactions to be legitimately audited by code that they are doing what they're meant to be doing. But after the fraud proof period is over, they don't need it on chain anymore, and that's when these temporal data will be lost or purged. But the main thing is that because the gas fees are high, that's why gas fees are high because they stay on chain forever. Now, when this is temporary data, basically it means gas fees can go down because you don't have to keep this state on chain forever. And that's the main reason why this will be a huge multiplier in terms of reducing L2 fees.
Yeah, and it's interesting to note that regarding this term data availability, you might be wondering, well, why can't we just why won't there just maybe a free why couldn't a free market emerge for providers of archive data? Like, hey, we don't need to worry about Ethereum upgrades or network upgrades. Like, clearly there'll be like different companies willing to do this, to essentially archive data or make that data available. The reason why it's so important is Ethereum is as a community and as a network has always driven itself to be maximally trust minimized, meaning that you shouldn't have any assumptions about what's happening. So let's say you don't want to leave anything to chance, and you want to be able to prove that immutability in this case in a certain amount of time. But also you don't want to have to count on a third party. You want to know for sure that it's there. The only way to really make that happen in the context of this protocol is to actually include it in the network itself. So that's where you kind of get into this, the specifics of this implementation with 4844. What this does is introduce a new sort of data structure called blobs into the network. I remember from my limited computer science schooling that blobs, it's a common sort of thing that it's used. It sounds amorphous, and it really is. I think it can be applied to different things, but in this case, the blobs are sort of what's facilitating this. Who wants to speak a little bit more to how exactly this is happening and how it interacts with, say, the execution and consensus layers that we talked about last week?
Real quick before we get into the technical stuff, I just want to say when I first heard this, word, I thought somebody was joking because it's a computer science word. And I thought they were just like, they said JSON blobs. And I was like, oh, okay, like just a blob. And then I did the thing where I Googled it and I'm like, oh, this is an actual term. It means something, it's abbreviated. But there's so many times where if you're not a computer science major, you hear these words and you assume it's just like slang. And then it's like, oh, it's something I should know. So I won't go into more about that, but I just think it's interesting to think about these terms and how they are not just a figment of someone's imagination. They just came up with this random word.
Yeah, this one was not made up by Ethereans. It was pre-existing.
I want to add something to like one thing Josh was saying about the keeping the data on chain. So this conversation has been going on for a while. Like we had this still ongoing conversation about like state expiry, or like the problem that overall we want to solve as like Ethereum wants to solve, and a lot of other blockchains also have the similar issue when they get popular enough, is the blockchain gets so big that it's almost impossible to have it on like a home computer. You need like servers, you need a lot of like SSD and massive hard drives, which reduces the ability to get in and kind of makes issues with like decentralization of the network. So like we had the state expiry, which the idea was like, oh, some of the older contracts we can delete them. But then the question is like, what if those contracts just needs to live forever, or like, so who's paying for those contracts that are decentralized? So there's a lot of conversations there, not really clear answers. It's all around there. But we're going to get to later in this live stream, we're going to talk about like Self-Destruct, which is another EIP that is changing some of that. And I remember early on, the idea was like kind of blockchain hygiene or blockchain development hygiene, as like if you deploy a contract, you play around with it. When you're done, call this, it was called suicide back then, but like self-destruct to remove the data from the blockchain. So it reduces the size of the blockchain overall for all the nodes. And this was like kind of given to the developers to do this. It ended up not necessarily working out the way they wanted, because they added like incentive models on top of like how this clearing the state would happen, which then we end up like gas tokens. I'm not gonna like tangent on that, but like there's a whole story behind trying to get this blockchain size like under control. And this proto-danksharding is like another way of like scalability and getting that size under control with the same changes, which is like almost 2 years in the making. Like it's not like something that like someone came up with like last week. Yeah, just want to add that. And where were we on this subject? Like we can just continue.
Thanks for that clarification, Cheyenne. But you're just talking blobs and kind of some of the details of how this is being facilitated.
If I can just add something to what Cheyenne is saying, like I think he makes a really important point about like the point of decentralization of nodes, because the whole point of moving to proof of stake, part of the point at least, was that proof of work didn't develop the way that we thought, in the sense that initially people were doing proof of work on their home computers, on their laptops, and it was truly decentralized. Then it got to a point with ASICs, FPGAs, and all kinds of hardware that was specialized. It became, you have to run a professional data center to be, to do anything in proof of work. So the whole part of the point of moving to proof of stake was to then re-decentralize this again to make it possible for people to stake at home. And if the data is so large that you can't get a consumer hard disk that can do this, you have to start building specialized machines that you need like 17 hard disks or something inside like a rack server. That is no longer in the range of the home consumer. So I think that a big part of this hygiene is to keep it within realistic bounds of a home user. It's still technical, it's still not the easiest thing in the world to run a node, but it's still within the realms of possibility. And there are lots of grants for people and incentives for people to run nodes at home as well. And I know Cheyenne runs a few nodes at home. So yeah, I think that it's really important to re-emphasize one of the reasons that we're doing this is to keep staking decentralized.
Yeah, thanks, Dustin. Again, making things as decentralized as possible is really the kind of the underlying ethos behind all of this. Ethereum has had a lot of different proposed different ways to scale, and also different ways to maybe approach consensus prior to the merge. But the community over time has always opted over things that are both practical, meaning something that could be implemented in the near term, if the intermediate term future, but also doesn't sacrifice decentralization for scalability. You guys, so I don't want to talk about this term too much, but you may have heard about sharding, the concept of a sharded blockchain. So just a little brief background. This was discussed initially as the path to Ethereum scaling. I remember back at DevCon in Osaka in, I think, 2019, that was kind of the big thing, is like, okay, Ethereum is going to be scaling by just having many sharded blockchains, kind of that way, basically every node wouldn't have to process all the transactions. And on paper, it sounds very cool. It borrows from a proven database concept, which is also the concept of shards. The problem is, in that case, the devil's really in the details, because you get into problems with what's called like cross-chain or cross-shard communication. How do these things know in a timely fashion what the other one is doing? And it gets really, there's a lot to it. So this may happen someday, but when everything, or basically what you guys need to know now is that that's just a research thing. And sometimes you might hear about sharding maybe in like a data context, but the scaling path right now is strictly just these this sort of layer twos, these rollups using Ethereum as security, and then using this new data structure of blobs integrated into the network as a new place to host data, because hosting data on Ethereum mainnet is super expensive computationally, and it's not feasible. Again, nobody's looking to post like an encyclopedia worth of details every 10 minutes. This doesn't need to be super intensive. Instead, it's more of like just this need to temporarily host the data that proves what the rollups were doing. So yeah, I see a nice screen share here. Let's talk about this a little bit more.
Just one quick addition to what you're saying, Kent. I think it's important to describe the mechanism in which these layer twos, these roll-up chains are actually communicating with the Ethereum network. They don't have like a back channel into that network that lets them, write these blobs, write the old data into Ethereum. That way you can, finalize transactions or commit checkpoints or whatever these rollups and layer twos are doing as they talk to the core Ethereum network. There's no like back channel communications that they get to use. They have to use the Ethereum transactions just like us. So these networks are actually spending ETH on gas every time they do these checkpoints, every time they interact with the main chain. So it's really interesting for them too that these fees go down, because it helps them actually be more efficient in their process. So because they have to, if I was to send a transaction and store a JPEG on the actual Ethereum network, that would cost a significant amount of gas for me. These people are basically trying to do that multiple times a day, or these networks are trying to do that multiple times a day to get their checkpoints in, to keep their network secure, to keep their customers and users secure. So it's by improving this process for every user, we improve it for them as well. But I just thought it might be, I feel like sometimes there's a missing link between how these networks are working and how they're communicating with Ethereum. And the answer is there's nothing special there at all. They communicate with the Ethereum network the exact same way we all communicate with the Ethereum network. Great
point, Josh. Yeah, and this kind of relates to you'll hear this term call data, where these rollups are using, they're currently active, but they're using this ability Ethereum has called call data to post things, but it's expensive and it's not really scalable. So yeah, you get into this issue of, well, maybe these rollups will get more expensive over time. Hence this need for this 4844 and this idea of blobs.
Yeah, and I guess to kind of hit the point that we were just seeing in that screen share too, the data needs to be in Ethereum if the Ethereum network is going to care about it. The Ethereum network, when a smart contract runs, it has no visibility out of the Ethereum network. A smart contract only sees what data is available within the Ethereum network and what's been written there by previous transactions. So if Ethereum network needs to know the balance of an address, and the answer is, well, the balance is on a layer 2, the Ethereum network doesn't know about that. The Ethereum network has no concept of what is happening outside of it. So this data needs to come in to get finalized. Otherwise, the network has no concept of that any of this is taking place.
So I want to get like one level deeper than that because we're talking about this upgrade. So yeah, as you were saying, like Ethereum, all the blockchains are like closed systems. Like that's why we have oracles. We have like oracle problem that communicate with outside world. On Ethereum, as if you've been following us for a while, like we've been talking about like the clients, and we have the consensus client, execution client. So we have execution layer and consensus layer on Ethereum. So execution layer is like what smart contracts are running, the code that Josh is talking about, the data that he's talking about is like on that layer. And we have consensus layer, which is more how the nodes are communicating together, how the proof of stake is happening. And on the same upgrade that we're talking about, Dustin was showing it on the screen for a second, but there's this other EIP called EIP 4788. We're not going to go that much into detail of that, but while the subject is here, I just want to like mention that. So even 4788, the one on to the left, so even the execution layer, which are the smart contracts, currently they don't have access to the consensus layer to know what's happening with the proof of stake. So even like that closed system is even within Ethereum as well. So like one of the things that this upgrade and this specifically EIP allows that is like to have the beacon block root as like with the latest state of the consensus layer available on the execution layer. So smart contracts can do kind of checks on like how other validators are working, how much rewards they have. Like it's still like really limited. There's like a bunch of other EIPs that needs to be like passed to have like, I think one is like 7002. I don't remember the exact names, but like there are other ones that allow smart contracts to be aware of the consensus layer, the validators, the latest balance, if there's someone that got slashed or others. And this is like the first of many other EIPs that even that closed system we talk about, Ethereum has like 2 closed systems inside there. So they need to communicate together so they can grow. I think that's good enough for that EIP that we had on the list to discuss. So we can get back to
a quick follow-on question, Cheyenne. I don't want to necessarily move it too soon away from the 4844, but I mean it really does underscore the point that there is other important EIPs here, and it also is like it's another reminder that you know, to maybe somebody that isn't too familiar with Ethereum, you might think it's just one monolithic thing, but this is a great example of how you have 2 different sort of layers or 2 different parts of Ethereum. You have the consensus layer and the execution layer. And with this new EIP, it's actually aiming to bring in more information about what the consensus layer is doing into the execution layer, where decentralized applications or dApps can do it. Cheyenne, what are some of the specific use cases do you suppose that, you know, dApps will be able to take advantage of once they have information about what the beacon chain is doing on the EVM?
Yeah, so like it's
real
mainly
quick and just say beacon chain is also when
consensus
we're talking
layer,
about consensus layer. So I put that in the chat, but the terms get confusing. So just keep that in mind.
Yeah. So yeah, like one of the main uses right now that this is like the first of the EIPs, first of many that is going to help me out is on like let's say liquid staking or all these protocols like Lido, Rocket Pool. And what they do is they create a kind of like a staking pool. If you are familiar with mining pools, it's a similar idea, but like there's a lot more complications around like who's lending the money to like the protocol lend the money to the node operator. There's like a complex system there. But what they do right now is their smart contracts need to know if their validators are doing their job and like how much balance they have. So they create these like oracle pools as like they're a bunch of people get together and their job is to fetch the data from beacon chain, post it as a transaction to a smart contract that the smart contract would have access to that information. So they can like know the latest balance of the validators or like some other aspects of it. So this EIP is like one of the parts that are required to remove that oracle, because like that oracle there is like you're trusting a few people or a system to like allow you to have this information available, and based on that information, you're calculating like rewards of the users, how much fees you're paying, like a lot of things that are essential to that protocol, and right now is trusted. So as you were saying, also like one of the main goals is to remove unnecessary trust and intermediaries in this ecosystem. And the CIP is one of the parts that like, oh, we can allow kind of cryptographic work to like fix this problem rather than having people sending this information there. So that's one of them. There's going to be a lot more probably. This is like creating the system that's all interconnected. So we'll see what people would do with it. But for now, that's a specific problem that is being solved.
Thanks, Cheyenne.
I have a question on blobs that we didn't answer yet, and I don't know the answer to it, so I was curious if someone else on our committee here did know. Is the new EIP that's going into place for blobs, does that allow the person creating the blob to set a specific time in which it gets destroyed, or is it all a standard time? Do they all last a month all the time? Or is it, always 10,000 blocks? Or can I say, keep this alive for X amount of blocks, and does that like change the amount I'm paying for it?
I'm reading
I'm
the
glad I'm
EIP
not the
to
only
find
one.
out.
Really good question. But my
I
take
know
is
that you
like,
can change the like number of blobs, and the price changes along with the number. And I know the goal is for it to be on 1 month, but I guess I don't know.
Yeah, I've
like,
seen that 1 month before, but I don't know if like, can I
Yeah.
change it? Like, can I have a quick on-chain message that like disappears? I guess this is one thing that's always like, you're never going to build a chat application on Ethereum previously because
Snapchat
the history is
sharding.
there. Yeah, proto snapshot. Oh my god,
Well,
because
so
it's just never going to make sense to keep that much chat history for that long. But
Well, we can actually go into the EIP. So like this is essentially like what, the process of upgrades are. The EIPs are readable by everyone, so it's not a secret. So we can see
I
the
mean, readable by
parameters
everyone
here.
is also debatable, but like, yeah.
I said readable, not understandable.
Yeah.
So we have minimum epochs for block sidecar requests, but that's minimum. Don't see anything about necessarily the duration, but we can keep talking. I'll just look at this and we'll see if there's something that answers that question.
Well, and we can, if we don't find it by the end of this, we can add it into the description, but this is such a good example of how much there is to keep track of Ethereum, and people that are extremely knowledgeable about it still can't keep track of everything that's happening in all of the EIPs. I think even core devs get confused, but this is a good lesson for all of us and for everyone watching, that we're not ever going to know all of the answers about everything in Ethereum, and this is how you get the answers. This is how our committee gets the answers, is doing the research. So yeah, good lesson.
Yeah, and I'm kind of looking forward to see, like right now, I think yesterday or the day before, this was enabled on the testnet, and we're gonna see that soon on mainnet as well. But I want to see when people would create this whole system of like sustaining the data there by like refreshing every 20 days or something like that. It's gonna be interesting to see what happens there, but we might have like a torrent movie on Ethereum. That's gonna be interesting to see.
So
One
I
thing
think
that Josh alluded to here, and you see jumping out off the screen here, is this idea of fees. There is a crypto economic sort of mechanism for fees. It's a little bit similar to how things work on the consensus side, and this is probably a whole separate rabbit hole. But it's just interesting to know that there's there is kind of a fee market for blobs, and my understanding is this is sort of to maybe A, prevent spam, but also B, allow for it just kind of prioritization. People that want to get a rollups that want to get a blob or data included sooner can pay a little bit more. I just thought that's interesting because it's not just sort of this thing that is accessible without kind of the use of or without a payment of fee up front.
So I might have found a part of the EIP that answers that question. it makes it possible to implement a policy that these blobs must be kept around for a certain period. The specific value chosen is around 18 days. So I think this parameter is what you would use to select the longevity or the lifespan of the blobs. But willing to be corrected if I'm wrong.
And I think one thing that is likely, you know, we kind of prefaced all this with the idea that you don't want to rely on off-chain sort of, you know, private holders of data or maintainers of archived data. But I think there will very likely be archived blob data just for the purposes of, I mean, you can think of a lot of different use cases for that, but I bet we'll see that. It's just from the standpoint of trustlessness, you always want at least in that period, you want that. And just to
It
reiterate,
already exists for the L1, right? So there are like projects like the Graph which already do that for L1 data. But then yeah, I completely understand what you're saying, that there will be a market for this for blob data as well.
totally. And why 18 days? I think the logic here was that and just to kind of reiterate what we were talking about earlier, ZK rollups don't need that long in general for data availability. They use advanced math to do their proving, and this doesn't require a relatively long time. Meanwhile, optimistic rollups rely on game theory, and there's this thing called the challenge period that typically is around 1 week. So this is more than twice that. So it gives some wiggle room. And in a sense, it was kind of arbitrary to choose that figure, but it was not completely arbitrary because it really is designed to meet the needs of rollups specifically. So yeah, a lot of details. So on the screen here, we're looking at some other EIPs. Before we jump into maybe self-destruct, which is another interesting one. What else what other thoughts do we have on 4844 and just this concept? Or maybe we're ready to move on.
Much like Cheyenne, I'm curious just to see it on Testnet and see how people start to abuse it. I think that's always the fun thing. I know a lot of effort goes into game theory and figuring out how people will use a feature. We'll actually talk about self-destruct in a minute, which is a feature that was implemented with one expectation, but then started being used in different ways that weren't necessarily as beneficial. So it's sometimes especially in distributed systems, things just go a different way. And with that one, it'll be interesting if this is a cheaper way of storing data. Does it still make sense just to rewrite it every 18 minus 1 days and use that data or use that cheaper fee while doing more transaction? So
basically
we'll
be like gas arbitrage, right? So like maybe you have data that you want to keep on chain, but maybe blobs are cheaper to keep it on chain, just that they live for 18 days. So maybe you just keep reposting it every 18 days, and maybe that's cheaper than putting it on the L1. That's
or you look for the cheaper time. Oh, it's been 7 days and something's being released in a week that's going to send fees higher. Let's rewrite our data today. That way we don't have to write it next week. Who knows?
I just want to jump back and say, Josh, you mentioned test nets, and we talked about this in the last session, but just to remind you all that the testing starts on the test net, then moves to the dev net, and then the main net. So that's kind of the process of moving along. So there is a lot of testing happening beforehand, and that's why Josh was saying he's interested to see what it'll look like on the test net portion.
Yeah, and one thing also, I'm excited to see what people would do, but one thing behind my mind, so I'm always good at breaking systems and figuring out how to break systems. Sometimes I don't even know how, but it just happens. Right now, one thing that makes me worry is a lot of recommendations for running a node, even my node that Rocket Pool is running here is 2 terabyte hard SSDs. There's a system of pruning the execution layer so you don't reach 2 terabytes. It got actually pretty close to a critical sense, so you always have to prune at least once a month. There's automated way of doing this, and by pruning I mean to remove unnecessary information so you have smaller blockchain size. But given that there's this proto-danksharding would be this chunk of data that every node needs to keep. Makes me kind of like wonder how it would, first of all, like just normal use versus like attack on the network, and how would that like make nodes go out of like hard drives? Because that's going to be a scary attack, because recovering from like a full hard drive is much harder than you think just removing files, because like it just gets corrupted. So in back of my mind, I'm kind of like worried about this, but I'm just hoping that there were like enough tests or like something that is these limits that. We'll see. But like also some people, I saw this conversation on Twitter somewhere that like there's this also conversation that because of these blob data, there's going to be less data on the blockchain. So the blockchain would like grow slower. So we'll see. And I feel like Dustin's showing like something about that exactly, like 2.5 terabytes per year. Sorry, but
Yeah, so this is like from so EIP 4844. So like the main place that you get EIPs is actually like Ethereum Magicians, but certain EIPs get their own website, and particularly it's EIPs that people feel are important. So EIP 4844 has its own website. So in the FAQ there's an FAQ written by Vitalik talking about the disk requirements from EIP 4844. And it also references a future EIP, EIP44s, which I'm quite familiar with because I've talked to one of the authors about it quite a lot, where there's history expiry. And that's something that's much further down the road. It's part of the purge roadmap. So that will also be one of the parts that I think would address what your concerns would be about, like the node storage.
Yeah, it'll be interesting when things go live. I think, to Jessica's point, the fact that all these are thoroughly tested beforehand, whenever there's an upgrade on multiple levels, including all the clients that implement this, it minimizes, of course, doesn't prevent, but it minimizes the probability that something crazy will happen with like an unforeseen bug. But then, there's the idea of like, okay, well, what really happens when this goes live? There's attack vectors, there's new crypto economic mechanisms. So kind of going back to what Josh was really originally talking about in terms of the things that could go wrong. Like at Shapeshift, we used to have a saying, testnet schmestnet. We even had that on some shirts, and it really spoke to like this idea of like, okay, you can test the shit out of something, test, but until it's in prod, and really in the context of a crypto blockchain or crypto network, until it's being exposed to the rigors of crypto economic incentives and attacks and things like that, everything from spam attacks to DDoS attacks to people trying to game the system, you never really know. So there's certainly no guarantee that it'll be smooth sailing, and that's part of that's part of what it means to build out in this frontier where we don't have any we're kind of designing these new things.
I think
The Lazarus group hackers aren't going to try to steal your testnet tokens, basically.
Exactly.
I think too, like we might think, oh, this is just what happens with open blockchains. This happens all over. If you ever do an update like on your iPhone, you'll do a big system update, and then you'll see there's like a ton of new ones that follow very shortly after, because it's the same thing. Once it goes live, they're going to notice all of these new attack vectors. So this is very similar with other types of technology as well.
Absolutely. Let's see, guys. We got about 15 minutes left before the top of the hour. We honestly, we could spend the rest of the time just talking about proto-danksharding and 4844 and really interesting topics. I think probably we could talk about it more in a future live stream. But
I like to point out, Jessica before this call specifically said, as soon as you say the words proto-danksharding, it's 2 hours later. So here we are. We have half a show to go, and we're at the hour.
You called it, Jessica.
I think it would be interesting to get into EIP 6780, primarily because I was actually on the Opcode devs call when they were discussing it. And what was really interesting is that they actually commissioned a survey that would figure out the impact of like EIP 6780, because there were actually two proposals that would basically destruct self-destruct. And they did a survey of like what smart contracts would be affected. And I think that was another interesting part of the all core devs EIP process, which is, figuring out what are we breaking when we do this. So I think that's a EIP worth going to, maybe not specifically just for the EIP, but also around the process around how do they decide which EIP to move forward to, and making sure that we're not destroying things along the way.
Great idea. Dustin, you had a front row seat to the kind of the discourse around the development of this particular EIP. To start off, what the hell is self-destruct? It kind of sounds like some sort of like James Bond thing, like a thing blowing up on its own, or like a robot, or what is the self-destruct opcode?
What are
I'll jump
opcodes?
in with, what's an
What are
opcode
opcodes
first
first?
and foremost. So opcode isn't something unique to Ethereum either. Opcode is another one of these terms that's been around in computer science for quite a long time, and it's really just the name for an instruction. So I think if we want to simplify things as much as possible, the CPU in your computer, the thing in your computer that does all the computations, has just this list of instructions that you can send it, and that's what the hardware knows how to convert. So if I open up my calculator and I click 1 + 1, what's actually happening behind the scenes on that computer is the CPU is receiving an instruction that says, this add as the instruction, and then 2 numbers. And then the CPU actually in hardware takes those bits and does the instruction and returns it. So it's a very low level way of the actual instruction that gets to your computer. Obviously, there's all sorts of graphic libraries and all sorts of nonsense between you clicking a button on your calculator on your computer and the CPU receiving the instruction 1 + 1. But ultimately, that's what an opcode is. It's the lowest level instructions that everything can be built upon. So if I want to, add 3 numbers, I don't need an instruction add 3 where I give it 3 numbers. Instead, I just use that add instruction because it's the lowest level instruction, and I might call it twice. So opcodes, the Ethereum, the EVM, is like a virtual CPU. It's a virtual machine. So the EVM has its own list of instructions that are the core things that it will do. And most of them are as simple as add, multiply, as simple as, and sometimes slightly complex, as in, verify the signature. Because you don't want someone building out the verify the signature function. It's complicated, it's cryptography. So this is a fundamental core instruction. Self-destruct is one of these core instructions that they thought everything needs to have because it was a bit of a corner case. Someone wants to describe it, otherwise I can describe what self-destruct was supposed to do.
I was just going to jump in and say, part of the EIPs considered for inclusion, there are EIP 1153 is actually transient opcodes, because now that you've introduced this blob storage, we need opcodes to handle blob storage. So that's another example of how you introduce a new thing. You need to have this lower level instruction that allows people to interact with the new thing that you've introduced to the system.
Perfect. So self-destruct was, it's in the yellow paper with one of the original documents describing what Ethereum was. And the purpose was, as Cheyenne alluded to, cleaning up after yourself. Okay, I've deployed a smart contract. It's in production. It's working. It's on Mainnet. Great. People are using it. Oh, I want to release a new one. I move everything over and I tell my clients, okay, start talking to this smart contract instead of that one. Well, it would be rude to leave your trash lying around on the Ethereum mainnet because this has to run on everyone's computer. So the idea was, well, let's include this self-destruct that will rip out this smart contract code. And if there's any value in that smart contract, if that smart contract holds ETH, transfer that to this address that I specify in this contract. So it was a way of facilitating upgrades to say, oh, this is hell, oh, there's a security vulnerability in this smart contract. I better run self-destruct and move everything to the new non-vulnerable smart contract. One quick swoop, great, it's easy. We have seen this used in horrible means in which contracts were deleted and maybe shouldn't have been. which was certainly an issue on at least one or two things. But ultimately, there was good intentions in this core opcode called Self-Destruct that was there to, again, help with people cleaning up code, help with keeping the chain size small, removing old stuff that doesn't need to be there, and facilitating migrations from smart contract to smart contract for developers. So it was a very well-intentioned thing. Didn't necessarily get the use that people expected, though.
Josh, you mentioned that this happening before accidentally deleting it. Was this what happened with the parity multisig bug, where the person that did this said I accidentally blew it up? Did they use self-destruct, or was that another vector?
It would have been self-destruct that was used in that. So if someone can correct me, they can. I know I'm fairly certain that's ultimately the opcode that destroyed the. Because I think that was the only way to destroy the smart contract.
That was a big deal, yeah.
And that's the reason we have EIP 9999.
So we just got on a little tangent there, said a bunch of stuff, and you probably didn't have any idea what we were talking about. There was a multi-sig system. So if I have a wallet where, let's say the 5 of us on this call each get to control those funds, 3 of us have to agree that, okay, if we do this transaction, 3 of us have to sign off on it. Great, that's multi-sig. That's saying, we're holding a wallet together and enforcing the constraints of it in a smart contract. This smart contract system, in order to be able to deploy those wallets with a much smaller code base, kept a lot of the core code in a different smart contract. So they kind of just released like little nodes up. There's node's a bad word for it because we use that for everything else. Little like headers of hardware wallets that then reference this big library. And this library had all the code in it. So all these different wallets that hold lots and lots of ether for people, doing it in a very secure manner. Everyone's happy. Someone realized that there was a function accidentally left in that big library called destroy. And the function for destroy called self-destruct under the hood. That function would be fine if there was some sort of authentication to it to say, okay, only this special user can call this. But it didn't ask for any sort of authentication. It didn't verify any sort of identity. It just executed. And once that library of code was gone, now nothing could happen in any of these contracts. Because if you tried to do a send in any of these hot wallet or in any of these smart contract wallets, the send function was over here in this library that no longer existed. Sorry for the tangent, but it's a funny story about how self-destruct can be slightly destructive.
A good tangent, very relevant to the conversation. Good ETH history there.
Yeah, and to continue on that, also it was like, so the idea for self-destruct was to be able to like clean after yourself or like remove this extra storage. But then later on, there were 2 like historical events that also resulted in like what we're trying to do with this EIP, with this self-destruct. One was like, so there was like incentive for people to clean after themselves. So if you actually deleted some storage, you would get some more money out of it. And it was not necessarily just self-destruct, but self-destruct is like the most juicy one that would pay back the gas and like the storage. So that was like a result that like a whole ecosystem of like gas tokens came in. So like you could, when the gas was cheap, you could just deploy a bunch of contracts, and the gas was more expensive. You could just self-destruct them and get more money back. And there was like some nuances that like the money would come back at the end of the transaction. So a lot of like people would, especially on attacks, they would just like do a lot of transactions, like doing a lot of swaps and like trades, and at the end would burn a bunch of gas tokens, who would get like most of the gas back, which was like an interesting use case, but something that like people were not like foreseeing like when this could happen. So one of the things that happened with like removal of like some of the self-destruct was like changing like the way EIP 1559 works and some other changes that the gas tokens kind of like, they were not important as much as they were before. But then also there was this other opcode called Crate 2, which the idea was like to make upgradable contracts that keep the address. So like a lot of times, I think we talked about upgradability a bit before, but like it's mostly people, there are different approaches. One is like create a contract that is linked to another contract. So every time you update actual code. You just update address on this door, like gateway. Another way is like to use this crate2 opcode to like update the code that is behind the address. And in order to do that, you can deploy the code, get your users to come in, then self-destruct and upgrade the code with something malicious or something that the users are not like okay with. And now, so that made a lot of like security made the security much harder because you could not trust even like the trusted actors in the system, or like there were like things that would happen that you can't predict. So the idea for this EIP is like to limit that self-destruct to the same transaction as the crate2. So like one of the best examples for this is like you're running an exchange, or you for some reason you want to accept deposits from users. One first way was like to create like normal addresses, get them to send the tokens to, and then you had to like send some ETH there to be able to pay the gas to send the money, send the tokens out. Another approach was like to deploy a smart contract so you can sweep or like transfer tokens out of the smart contract when the user deposits. Another approach right now with the crate2 and this option is to predict these addresses, and when the user transfers the tokens to that address, you could send this transaction that creates that smart contract, sends the tokens out, and destroys that smart contract. So you would not take more space in the Ethereum in the blockchain, but also you don't have like leftover gas in that. There's like a lot of like practical use for the way the CIP let us use self-destruct that doesn't have as much of the security concerns as before. Basically, like it's limits the use of it to just one transaction compared to like before that could be any way to be used.
Hey guys,
yeah.
what about the problem if you're a dApp developer, you have code out there on the blockchain that currently uses self-destruct? The term that we would use in crypto would be like it might introduce breaking changes. I guess that's just a general term as well in programming. But all of a sudden, are users of these or smart contracts that employ self-destruct in the wake of this, are they still going to be functional, or does that present any challenges?
So one of the things that they did was the Ethereum Foundation commissioned DDoB. I'm not sure if I'm pronouncing the name correctly, but they're a security audit company. And what they did was they did an impact study on what would happen in the result of the removal of self-destruct. So just quickly jumping through it, there were two EIPs that you could do self-destruct, get rid of self-destruct with, which was 4758, and the one that's now considered for inclusion, 6780. So they just did a survey of smart contracts, and they just went through all of the smart contracts and went, okay, what is affected by these two flavors of the EIP? So these are the different implementations based on the EIPs, and then this is the one that's considered for inclusion. So these were the projects that they determined would be affected. But you see the asterisk here says, impact is high, but the contracts are actually upgradable. So the thing about contracts like that is that because the word is metamorphic, which is they can be upgraded in place. So even though the impact is high, if you have an asterisk, it means that you still can upgrade your contract and you can upgrade it in a way where self-destruct doesn't break it. So then they just did a further impact survey, and they broke it down into exactly what Cheyenne was talking about, which is like a short-lived smart contract, which is it creates and destroys in the same transaction. A short-lived metamorphic contract, which is it creates and changes the underlying code in the same transaction. And then a long-lived metamorphic pattern, which means that it creates itself and then it destructs in a different transaction. And both of that would be disallowed by either EIP. Going into like a little bit more about the survey basically they searched through everything, and then the conclusion was that wait, let me find the full report which covers this a bit better. So to Cheyenne's point, he was saying that a lot of it was used by MEV bots. Not many known projects use it, and it doesn't affect like very well-known projects. And the ones that were affected, like XLR Network, which is a fairly big project, it has a upgradable contract. So this is the survey that was done to say there are impacts, but these are the impacts, and it's generally doesn't affect many well-known projects. The ones that do can upgrade it, and who it mainly affects is MEV bots.
It looks like a super in-depth and thorough study. And I think it really speaks to how deliberate of an approach is taken with respect to all these EIPs. It starts on some of these forums like Ethereum Magicians and Cat Herders and really in the community. But that's kind of the beauty of having a decentralized community-based approachment with respect to development, as opposed to, 3 developers in a room or in a Slack or Discord figuring things out. This is like really leveraging the collective brain power of the Ethereum community, which is so powerful. I think it just leads to more nuanced EIPs and actually we're a little bit over time here. I wanted to wrap up on a related point and just kind of tie everything back. We actually weren't able to cover the rest of the EIPs. We have a couple other ones here. Their numbers are not important, but what matters is like there's one EIP that improves the way storage is handled. It's a storage opcode optimization. So this should make in some cases storage cheaper. It would cost less gas, less fees to use that computational primitive on Ethereum. And kind of the big theme is like you have these sort of big picture upgrades, like the merge was certainly the kind of most impactful, I think, maybe ever in Ethereum in terms of like, my God, we're swapping out the consensus mechanism. That's a big deal. This 4844 is a very big thing because it facilitates cheaper scaling via the rollups. But at the same time, you have in any given upgrade, you have these like little small improvements that aren't necessarily game changers or make huge impact on Ethereum, but still make it better to use for developers or maybe ultimately users. And it's just kind of a cool theme, a common thread you see throughout the upgrades. So we're at time, but actually we're over time, but hey, this is fun stuff. Does anybody have anything, any final things they want to talk about or briefly mention before we wrap up for today?
Yeah, I wanted to like when you mentioned like the merge being like the one of the biggest upgrades, like sometimes I look at it as like outside Ethereum, the impact of it. And like merge is one of those overall software upgrades that I love because like it reduced the global electricity consumption by like 0.2%. And it just blows my mind every time I think about it as like a software update reducing that. And like we need to incentivize that kind of like behavior more, even in centralized systems, because no one really talks about that and everyone like just pays the carbon credit. Rather than that, like you can just remove this. And I love that. Like on Ethereum itself, it reduced the consumption, like power consumption by 99.5%, which is insane. But the global impact of it is something that I really like to and like to see more as like people talk about it.
I think I'm happy to report that a number of people who were working on the merge, like you were saying that I feel like this is the most impactful thing I'll do in my life, which is like reduce the carbon output of the whole network.
Well, and we see huge changes like this that make a difference beyond just like the tiny scope, and it builds and builds, and it really does what we want it to do, which is change the world in a way that actually is good. And so I think that, yeah, it is incredible to see the technology that we all care about do things in a way that we can feel really good and proud of.
Yeah, and have fun while doing it. That's like
Yeah, for sure.
That's the most important part, right?
Absolutely.
Cool. Well, that will conclude our time together today. Thank you very much for tuning in, or if you're watching maybe a recording of the stream later, thanks for watching. As always, C4 is here to help as your non-hypey resource for all things knowledge around Ethereum. We also cover Bitcoin as well, and even security best practices.
Yeah, and we just released a new course that's free about hardware wallets. So if you're interested in learning more about how to use a hardware wallet and what you should be doing with your seed phrase, what is a passphrase, all of that, you can head over to our website in the next couple of days. It's going to be available for everyone to take.
And you can send our seed phrase to info@c4. Like,
God.
no.
Well, thank you all.
Please don't.
All right. Thanks to our rock stars today. Thank you,
Have a good
Jessica,
one.
Cheyenne, Dustin, Josh. Peace
Take care.
out. Everybody have a good one.